Hello guys, today we are going to see the project demonstration of an IoT-based transformer health monitoring system. The concept of this project is we are going to monitor the transformer's health condition. For example, in transformer we need to monitor three different factors. One is the oil level, and another one is the temperature, and another one is load. Temperature, oil level and load. These three factors will determine the transformer's health condition. So all these informations will be monitored using IoT, which is nothing but Internet of Things. A web server is going to monitor the entire health conditions. If any abnormality happen, the IoT system will automatically respond to the particular user. So this is the block diagram of this project. So this is a block diagram. So here we are going to use a Arduino microcontroller, which is connected with sensors like temperature sensor, ultrasonic sensor. Ultrasonic sensor will check the oil level regularly and will update the microcontroller, and the voltage sensor, LCD display, Wi-Fi module, a GSM. GSM is used to send a SMS notification to the particular line in charge about the transformer health condition in case of any abnormalities, and the buzzer to give warning in case of high temperatures, and there is a relay in case of any abnormal health conditions. For example, if a transformer is going to get failed due to oil level or overload conditions, then the relay will automatically turn off the supplies and turn off the supplies to the load, and it will automatically send a SMS to the line in charge that the transformer is going to get failed. So, and here we use some kind of potentiometer and this kind of things are there. So it will vary the load. So accordingly, if you overload condition achieved, means the microcontroller will automatically shut down the load. So this is the block diagram, and this is the software end. In the software end, we are going to use a cloud server, and IoT application was developed. So all the informations like temperature, oil level and load conditions, so complete information will be uploaded to the cloud server. So the cloud server will record the data 24/7. So whenever the problem occurs in the transformer, we can easily identify at what time and what are the reason the transformer is getting failure. So this is the basic abstract. So let us see the live demonstration how the project will work.
Transformer health monitoring project. In this project, we can see Arduino Uno. This is the main microcontroller of this project. Here we use Atmega 3280P. This is the microcontroller which we using Arduino Uno. This is Node MCU, and here you can see this is LCD, 16x2 LCD. This is ACS 712 current sensor, and this is ultrasonic sensor, which is used to measure oil level of the transformer. So this is the power supply unit for this project. So here we use 220 volt to 12 volt step down transformer. So this will convert 220 volt AC to 12 volt AC, and here we use full wave bridge rectifier since we require DC current for the whole microcontroller circuit. So for this we will be converting 12 volt AC to 12 volt DC. We will be using regulator 7812 positive regulator, so that we can get accurate 12 volt DC without any fluctuations. And here we can see 7812 regulator, 7805 regulator. For Node MCU, we will be powering using 5 volt. So we require 5 volt, so that we will be using 7805 regulator. So that's all about the hardware description. And here we see LM34 temperature sensor, so which is used to measure the temperature of the transformer. Let's start the working demo. I'm turning on the power. So you can see light glowing here in ACS 712 on display. Here you can see the temperature, which is 27 degree. This is our room temperature. This is distance from oil. So we will be placing the sensor in transformer. So from oil level, so 16 centimeter is there, and the current sensor which is here, the current which I am using here is measured here. This is 12 milliamps. That's all. We can see now I am increasing the temperature. So I am using the soldering rod to increase the temperature. Since I am just nearing that. So you can see the temperature is increasing. So you can see T37, T38. This is the LM34 sensor which can measure up to 120 degrees Celsius. So it is increasing 73, 77. So which will be increasing. When the ultrasonic sensor is placed in the top of the transformer, so we can easily measure the oil level. So oil ultrasonic wave does not get passed through, so that we can get the distance from the oil level. So this circuit takes around 1.2 milliamps. Sorry, 1.2 amps. Since this is an IoT project, so we will be connecting our mobile internet to the Wi-Fi module. So for that we need to configure the SSID. So our SSID, so I'm turning on the hotspot. So you can see portable hotspot. So set up portable hotspot. So our SSID name is IoT. So small IoT, and the password is 12345678. So this is our password and this is our SSID name. So we will be turning on our hotspot. So you can see the device is connected. So you can see the connected device is what, ESP31FA60. So this is a ESP8266 module. So that is connected to our mobile hotspot. So since this is an Wi-Fi module, so this will be acting as an client side. So we will be sharing our internet through hotspot mode, and that will be receiving the internet through Wi-Fi mode. See the data in our IoT web page. So you can see our web page. Just open Google Chrome. So you can see the all parameters which we are measuring. You can see in the web page. So this link can be opened in either mobile phone or laptop or PC. So measuring, and I am just measuring the distance. So you can see the web page. So that you can see all the details in the web page. So this is the purpose.
Hello. Hello.
So you can see the distance is changing. Since I am changing the ultrasonic sensors position, so that is changing. So current will be there, and the temperature. So when I am changing that, the temperature will be rising. The temperature. So you can see the history also. So that will be stored in our database. So I am clicking the history button. So you can see for each and every seconds data will be shared, and that will be stored in a hotspot. You can see all the details here. So that's all about the project. Thank you.